To be honest, it kind of matches observations. Now, why is the Earth spinning and the Antarctica spinning the other way? We don't really have necessarily an answer for that. Thank you very much. Interesting. Thanks for the answer. The psychology of all this fascinates me. It fascinates me. It really does. I am really interested in this whole, whatever you want to call it, mental block. And as people come along, as we interview them, I'm wondering if we will see that they all had that and that they all see, because what I've noticed that too, we all look back and are very surprised that we were involved in it, are appalled by the people in it now. There is no really kind of connection that like, oh, I miss that. Oh, I miss being with those people because of the way that they have acted. It shows that we were not involved in a scientific pursuit. Because again, and for everybody saying Jaron left because he saw one thing, well, that's kind of true. And the truth about that is, again, the Earth needs to be, or the South needs to be a lie if the Earth is going to be flat. That's just required. And so I thought everybody knew that. And if, you know, in my mind, as a human race, we need to move forward with what is the truth and leave behind the things that are not. And this should have been done thousands of years ago, obviously, but at this point, it's okay. Like if all the flat earthers just said, okay, I still kind of feel it's flat, but I'm going to give up the pursuit of yelling and screaming in Facebook comments. I'm going to give up the idea of yelling and screaming at my family. I'm going to give up the idea of going to children's schools and trying to hand out pamphlets through the wire fence. You know, we're not doing that anymore until we have a model that can compete, right? And then you go back to the drawing board and you try and find a model. Did you guys see this model? I don't know if you've seen. Now, I want to give credit to this person because everybody else has not done this. Only Chris Crum went and worked on a model. I'll show you what he came up with. And it's not very realistic, but at the same time, I want to give him credit because nobody else has done this. Let me find it for you. Where is it? Over here somewhere. And I actually thought, hey, you know what? More love to you for at least trying. So this is his model here. And to be honest, it kind of matches observations. Now, why is the Earth spinning and the Antarctica spinning the other way? We don't really have necessarily an answer for that. But I mean, I give him credit because this is something that, again, notice it is an AE map. This is why I say every map has to be an AE map. You can't change this part of it. Oh, sorry, over here. You can't change this part of the map. Now, you got this here. I don't know why. Now, because this would show, for instance, the sun would set right to left here for this observer, right? This observer would see that setting to his, oh, maybe not. I have to think about that one. I don't think it would match that. I thought maybe it would, but no, maybe not. But it just would match the person standing here. So if here's Union Glacier, right? When we looked south, when we saw it above Australia, and then we would kind of still come around, and then it would be above Africa. And then when we get all the way around, it's going to be even here with South America. There we go. So it is kind of closer, but again, this is pretty much the extent of what you're going to see, right? There's nothing else coming out. There's nothing, and even this doesn't make sense because, I mean, flat earthers are in love with the fact that the Earth is stationary, and this, of course, requires the Earth to move, and not just move, but it requires Antarctica to move opposite of it. Again, there is a model that does that for you just as a feature of the globe, right? That's what it does. That's what it do. So, but you know, shout out to Crum for being one of the only people to actually do something. Try it. Oops. So I want to bring this up real quick. This one here. This is the best site for anybody who still believes that there's no model, because this is what this is. This is a model. And when they say it doesn't jive with the stars, it does. See the stars out there? So here, if you want to see why the North Star spins the way it does, if we kind of look from the bottom up, now you should know if we move the time or date forward, we'll move the time. Here, if we move the time forward, you can see that the stars work counterclockwise in the north. Okay, so if we kind of tilt this globe, we can eventually see where the North Star is. I think it's right there. Should be this guy. Let's see if it be, and move that time. Yeah, so you see all the stars rotating around Polaris, but you do see Polaris moving a little bit, right? So this does jive. Now, if we flip this around, we want to look at the south. Okay, the only difference being that we're not going to see a star that they rotate around. Here we go. Move this forward. And now you see that those stars down there turn clockwise. Okay? That's how that works. And if we pull it, I don't think it lets me go past that. So let me see if we can find the spot that they go around. So we're a little bit under it. So it's about there. Let's see. Okay, so the sigma is kind of down, oops, maybe in this region here. So we can see that. There we go. So now we're just going around that spot that has no star. Oh, you can't, sorry, you can't see as well that way. How am I going to be able to make you see that? Anyway, it's down here a little bit. It's about where my mouse is down there. So anyway, it jives with all the stars. Okay. And let me explain something because I don't think people understand this yet. Very simply, every observation we make from Earth matches this model. Okay. Matches it pretty much to a T. Now, again, you might find some sunrise, sunset times that are off a little bit, and that's because of topography. For instance, where I live here at the foothills of the Sierra Nevadas, we've got a large mountain to our east. So what this thing would tell me was my sunrise time would be off by a few minutes because the sun wouldn't be high enough over the mountain that I'm next to. So again, this model doesn't take that into account. I think if you go to SunCalc, it would. But this model is very mathematical and does not. So again, play with this. It's Andrew Marsh's. You can find it on my t.me/Jeranism links. I'll also put it in the chat for you. Okay, there's no reason why at this point you should allow somebody to say that we don't have a model. Okay, we absolutely do. There is a model. It's well defined, well explained, and it predicts everything. So that's another thing that I don't think people get. Here's the difference between a globe Earth and a flat Earth. Because right now you've got Shane and Alan and these guys, Space Audits and Shane St. Pierre. They're very good at now dictating what we see, right? So of course we know what we see. That's not difficult. Everybody can do that. So we can go out and say, oh, I see the sunset here. Oh, I see the sun go over my head at 90, rise at 90 and set at 270. Great. Now you can't just place that on a flat map. Why not? Because there is no explanation for it. What's the difference between that and the globe? The globe includes the explanation. So when you say, well, why does the sun rise for everybody at 90 and set at 270 on the equinox? Then the globe shows it. So you can say, well, let me show you. This is the globe. So now we're about to show you why that's the case. I found you infuriating but awesome now in my old debates. Well, we're going to look at throwback. We're going to go back to a Flashback Friday. And we're going to look at something from Odyssey today. Although I was thinking about putting all my old shows into my wheel, spinning the wheel, and then having to address each one as they spun the wheel. But we might just pick one for today. But anyway, so back to explaining why that is. So then what you could do is you could bring this over to the equinox, which is going to be, right there, March. We'll go to 21st. Okay, there's March 21st. We're on the equinox. So now we can take our latitude to, this longitude or latitude? Yeah, latitude, let's go to longitude. That one. Okay, so we can take our longitude anywhere, and you'll notice that if you look over here at the daylight hours, they're the same for everywhere. 12:05, 12:07, 12:05, 12:07, 12:10. Okay, it's all the same. And the reason that there's a little extra is because of the atmosphere and the light that kind of hangs around for a little bit. But then if we looked at why the sun rises at 270, and I'm sorry, why the sun rises at 90 and sets at 270, we'll just go to the time and we will pull this back. Oh, let's pull, and down here, you can't see it, but I'm turning on sunbeam. I'm turning on the subsolar point. We'll go ahead and turn on twilight. We'll turn on the tropics and the circles, okay? So now we got everything on there. So you can see that if we wanted to see why does the sun rise at exactly 270 here, let's go to the time, which is here. Okay, so watch the sunrise here as it comes around, and you'll notice that it's going to rise. See where it says sun there, the arrow? So you'll notice that it's going to be exactly at 90 degrees for that person there as it rises, and it's going to set at exactly 270. Okay, great. But why is it that that's the same as somebody else? So let's move somebody else on the globe. Let's go up a little bit. Okay, so or down, let's go up. So if we go here, why does this person see the same thing, right? So let's go down to the time. And now we're going to watch the sunrise for them. Okay. And you can see the blue line there. Let me kind of spin this around so you can see. Because remember, these rays are coming in parallel like that. And you can see as the sun comes up and rises, it's 90 and 270 for everybody. So that's a nature of the globe. That is because of the equinox. And I think I showed you, and I can bring it up again. Oh, I've already shown it, where I showed that the solar system model that shows how the equinox works, if you kind of think about it, the equinox is when you'd be looking at the globe like this. Okay, let me show you. Let's see here. This way. Okay, notice that right now the globe is cut perfectly in half. Oops, am I showing you that? Yeah. So it's cut perfectly in half. So what that means is everybody gets 12 hours and everybody gets 12 hours. 12-hour day, 12-hour night, right? It doesn't matter if you live here, or if you live here, or if you live here, or if you live here. No matter where, you have 12 hours on one side of the ball, 12 hours on the backside. That's the equinox. Now, if we move time, so now I'm going to change the date. Okay, I'm going to move it down here, actually. Okay, so let's move the date, and you'll watch how the sun is going to go. Which way is it going? Up, right? If I'm going towards June, because it's going to be at its northernmost point. So when we get to June 21st, it's going to freeze about there. Okay, so there we go. We're at the northernmost, and now it's going to start heading down. Okay, and you'll notice, pretend like, you can almost pretend that we are, well, no, you don't want to do that. But as you come down here, then you're going to get back to the equinox there, and then you're going to come down to there. So that's just kind of showing you the tilt from another point of view, and kind of shows you the sun. So if we are the sun, okay, now we're the sun. So notice that on the, let me kind of get in line with it here. There we go. So now you'll notice as we go south, north, and equinox, and equinox. Okay. So you can see how the globe Earth explains, why do I have a sunset at this time? What is the angle of my sunset? Why is there a polar circle? What does the northern polar circle have to do with anything? Right? Well, we can watch that and we can say, well, let's see what happens as we go through the year. So if we're here, notice that we are in December 21st. Oops, go back there. December 21st. Notice that the north is in full darkness, right? And if we move the time along, we're going to see that the north stays in darkness. Look at it. Notice that nothing inside that black. Now you'll notice here it gets a little bit of light, but for the most part, you're talking about no sunrise. You wouldn't see the sun. So this is what the flat earth cannot do in any way, is explain any of this. Okay, so in the south, of course, it's getting 24 hours of sun right now, as you can see. And then if we move the date, we would then, let's go up to June. And now you see that the south has 24 hours of darkness. So that's the difference, is that science is supposed to explain. Okay? Anybody can say, I see this, I see that. And we could apply it to whatever map we want to and just be like, it just works. No, but what map explains it? What map predicts it? And there is only one model that does that, and it's the globe model, and it is pretty much as perfect as it can get, barring, of course, anomalies with the atmosphere, anomalies with refraction, but it's such a small amount that should we really worry about it? Okay, so pretty much that's what you need to check out, and there's just things on here that prove that the model is symmetrical. Okay, where does the sun go at night? Thank you, Connie. It's behind you, that's all. But it's a very symmetrical system in the way that if we, let me turn off this stuff here. Okay, so it's very symmetrical in the way that if we go to December 21st, there we go. Because again, the reason I'm pointing this out is just to remind people that if everything in the north is flipped and it's the same as the south 6 months later, then we have to ask ourselves what shape would allow that to happen. And the shape is, of course, a sphere. So if we go to December 21st and we take this latitude line, let's go all the way to the bottom. You'll notice up here we got 24 hours of daylight because we're December 21st down there in the south. And as we start working our way up, notice that it goes up from 24. It's going to go to 22, 20, 19, 17, 18, 16, 15, right? Notice the time. It's moving in perfect unison with the heading to the north. And when we get all the way to the north, we're going to have 0. Okay, there you go. 0 hours of daylight. And then the same thing is flipped. Now we go back to June 21st, and you'll see that the same thing becomes flipped. Now we can take this and go down. Oops, didn't mean to take that. I meant to go here. So now we can take this, and as we come down, you'll notice that it's at 24 hours, and then we'll go quickly to 19, 18, 17, 16, 15, and all the way down. So any question that somebody asks you about the Earth, you can answer with this model. So it does work, and it is complete, no questions, right? If somebody says, well, why does somebody in the middle have 12-hour days all the time? Well, yeah, everybody about right here has 12-hour days no matter what. Doesn't matter the time of year. Let's go to the calendar. And notice the hours over here, the daylight. And if I take this, you'll notice it doesn't change much. So yeah, 11:50 to 12:10, basically. They have a difference of 20 minutes, or 12:20 I saw. So pretty congruent with the idea of the sphere being symmetrical and doesn't fit a flat earth. Just doesn't. Does not fit it anymore. Now, again, the reason I brought this up is because if the South turned out to be a lie, then you have competing models. Then you have to start asking questions. You have to look into it. We have to figure it out. But if it doesn't set, which it didn't, then this model is correct. And you can figure out in the North. Now, Dave said he couldn't figure out why the sun was at such an angle. And then Joe Hamby thought it was right above the North Pole. So I think that people think that the sun goes way high or way low. Just remember, it's just going a little bit. So if we go here, let's just turn on this one more time. There's the sunbeam coming from a distance. Okay. So it's not like a huge amount of variance. It's just a little bit. And so it's not going very high. Let's go to the date. You'll notice that at its highest, which will be June 21st, you're right there. Okay. So remember that you're looking at this side on, this is the highest that it gets versus the Earth. So it is pretty low for somebody standing at the North Pole. And if you can go test this in your garage, but where's going to get the most heat in this ring here? Well, you should know that it's going to get the most right here, right? It's getting the most amount of heat per unit, capita, whatever you want to call it, per square inch, per square mile, whatever. The most amount of heat focused on that area. And then if you're here, you don't get the same amount of heat because, number one, all this rays are not hitting you. So it's kind of like glancing blows, and that spreads out on this entire area. Okay, which is why the polar ice, or the poles, doesn't really, well, at least the South Pole. The North Pole is kind of a pool of water, and then it gets icy and then water. But in the South, it's just a frozen tundra because it doesn't get enough heat. So let's move it down to December 21st. Okay, oops, not 31st. There we go. Okay, so that's the lowest that it goes. If we kind of tip this up to see what we're getting here, you'll just notice that that heat is just glancing off the south, so it never gets hot enough here to melt that ice. It never gets over 32 degrees there. So that's basically a working model. Now, I don't know what else people want, but you can look at sunrise, sunset times. So what do we have here? Twilight. Oh, no. Where is sunrise times? Site, location, date, and time, solar out. Oh, rise set. So here's the rise set, 6:06 and 17:59. And if we take this, I just want to check this, and we go like this. I don't even know. Okay, 6:15, 7:29. So you can just see it's basically the same. I mean, it must take into mountains into account. And then also maybe even time zones. Not really sure on that one. But everything is explained. So clearly, flat earthers are at this point going to the levels of just making things up. I don't know where they're getting that from, that there's no model. But I've heard a lot of people say it. So I just want people to be able to combat that and say, nope, there is a model. All right, let's